we incorporate what people tell us, what we've seen, and the context in which we're asked about it. And memories are reconstructed into a way that fits with the environment that we are in. Now, some of you have probably been wondering when the brain gets into this. This is the only brain you're going to see, other than the one in the jar at the beginning. This is a picture of the brain being pulled a little apart so that you can see the corpus callosum, which is this really thick bundle of nerves that connects the two hemispheres of the brain. And when people suffer from epilepsy, what happens is that neurons will start going blink, blink, blink over here, and they'll activate other neurons and blink, 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 and it'll spread throughout the entire brain and cause seizures and all sorts of nasty things. So in extreme cases, some people have had their corpus callosum severed so that if a seizure starts in one hemisphere of the brain, it's not going to spread to the other, and any damage will be minimized. What's interesting about this is that the two hemispheres of the brain then become fairly independent. And most of the language processing and sort of conscious abilities that we have are in the left hemisphere. And more unconscious, big picture type stuff, visual perhaps, happens in the right brain. The whole, by the way, left brain, right brain, are you a left brain or a right brain person is silly. You use both of them most of the time unless you have had your corpus callosum severed, in which case you do use both of them, but they are independent, almost. So a person almost has two independent minds that have difficulty communicating with each other because their communication pathway has been severed. So here's a video of a guy who is a split brain patient. He's working with a researcher called Michael Gazzaniga, who's done some really interesting things with split brain patients. And watch what happens when he's asked to make a decision and he's getting conflicting information to his two hemispheres of the brain, and they can't talk to each other to say, well, I saw this and you saw this and they're different.
Yeah, it must. This time, instead of naming the word, I want you to point to the word.
Again, Joe sees two words simultaneously. Bell goes to his non-speaking right brain. Music to his speaking left brain. When asked to point to a picture of what he saw, he chooses Bell. But when asked why...
Yeah, why'd you pick that one?
Music.
Music?
And when asked to explain...
It was music and Bell, and those few minutes ago, last time I heard any music was coming from the bells out here. Banging away.
So the bells outside here?
So, look, good enough answer to me.
What's extraordinary is that Joe's speaking left brain concocts a plausible story of why he pointed to Bell, even when some of the other pictures more obviously represent music. Gazzaniga believes this determination to find cause and effect, this desire to explain, is the left hemisphere's most marvelous property.
One of the unique things to the human brain is this need to interpret why two events occurred. What was the antecedent to this? What caused this? And if you can imagine that a species like us that has that little chip in its brain that asks those questions is going to survive rather well, because it's going to figure out more about the nature of the world than a species that doesn't have that.
Okay, Joe, I want you to keep your hand...
But as I was about to discover, the right brain has a very useful survival skill all its own.
What do you think will happen here?
So for you, we're doing a live experiment. Never done it before.
The experiment involves the 16th century Italian painter Arcimboldo, who made faces out of fruit, flowers, meat, even books. From other research, there's reason to believe that the ability to recognize faces is located exclusively in the right hemisphere. So Mike wondered if Arcimboldo's paintings would look different to each of Joe's two brains.
So will his left hemisphere say, I saw a potato, I didn't see a face? And will his right hemisphere say, I saw the face, and not comment on the fact it was made out of a potato?
You're going to see a figure followed by a choice of two words.
If this works, it'll be terrific, but we'll see. So here it is, live.
Okay?
The first painting goes to the right hemisphere. And Joe points to face. The next painting goes to his left brain. And this time he points to fruits. Mike seemed pleased. Are you having a moment?
This is too good.
Again to the right brain, and Joe sees it as a face.
Point it down.
But to the left brain,
Face made out of books.
Point it up.
Pointed to books.
are you happy with what you're
Fruit.
seeing?
It's unbelievable. He's doing it. You see that?
It's good. It's going so fast. It's shifting from left to right so fast. I can't keep up with you. You're used to looking at this.
When you show him a face in the right side, the left hemisphere,
Yeah.
he's focusing in on the elements that made up the face.
Yeah.
When you show him the exact same picture in the left field, going to the right hemisphere, he's focusing on the face and not the elements.
And not the elements. If you came down from another planet and you saw faces and vegetables, you might not think there was much of a difference among them. But the brain seems to be made up in a certain way to say faces are very different from other objects.
That's right.
And one side of the brain specializes in faces.
Exactly right. Exactly right. It is an adaptation that we have to detect upright faces. It's a very important. You can imagine in an evolutionary time that all of a sudden you have the ability to detect quickly an upright face. You want to read the expression on that face. You want to know if it's friend or foe. You want to have a set of questions about that face.
The right brain might be skilled at recognizing faces. But when it comes to what gives the human mind its power, the ability to reason, to invent, to interpret the world around it, Mike Gazaniga's 30 years of research has taught him which hemisphere he wouldn't want to be without.
The old phrase around our lab is, don't leave home without your left hemisphere. That's where the action is.
So his non-speaking right brain sees something, and he points to it, and he can't understand why he did it because the conscious part that can explain things saw something completely different. So after making the decision, he confabulates. He makes up a reasonable explanation for what he just did because the reason that he actually did it is unconscious to him. He wasn't aware of it. Now, you might think, well, this probably only happens with people who have had their corpus callosum severed. It's something that, you know, it's weird, but so is his brain. Some very recent research is suggesting that this happens in normal, healthy people like us. This part was fun to research, by the way. So we have two pictures here of some models from Google Images. And this was basically what subjects would see at some research done in Sweden, I think. And they would be shown two pictures and asked to pick one. And then, after they picked one, the researcher, using some sleight of hand or the change blindness flicker paradigm, it varies and they've replicated in a number of different paradigms, but they swap the images and then hand the one that they did not actually pick to the subject. So let's say, you know, I'm picking that one. And then the researcher says, okay, here, I'll give you the one that you just picked. Swaps them and hands you that one. And then asks you, why did you pick that one? And the person will think about it for a moment, look at it, and say, well, I really like blondes. And I just kind of like the way that she's sort of like not looking right at me, she's looking over there. He didn't pick the blonde. He went for the brunette.